The topic of this video will be a bit more theoretical than previous ones, but don't worry, I'll try to keep it as short as and as easy as possible. We want to see the sum between two integer numbers and see how it works in practice. Let's review the addition as we probably learned in primary school. We have to add up these two numbers, 3 digits number. And of course, we put them in column and we sum units with units, tens with tens, hundreds with hundreds, and so on. Well, so let's start. Here we have 4 plus 3, which of course makes 7. And then we have to add the tens, and here we have 7 plus 5, which makes 12. And of course, we cannot write down 12 here. We have to write 2, and the one is a carry. We have a carry, and this carry has to be added to the 100. So now we add up 3 plus 1 plus 1 carry, which makes 5. And this is the final result. So with binary numbers, addition works pretty in the same way. Let's see it. Here we want to add up two 3 bits number, 0, 1, 1, 1, 1, 0. The first is 3 in decimal number, and the second one is 6. So firstly, we add the least significant bits, and you see in this case we call the two numbers A and B, and the 3 bits are A0, A1, A2, B0, B1, B2. So first of all, we want to add A0 with B0, and of course the result is 0, so this is easy. Then we want to add 1 plus 1, these 2 bits, and in this case the result is 2, or in binary 1, 0. And of course, we cannot write 1, 0 here, as happens in normal decimal addition. We have to write 0, and then 1 is a carry for the next addition. So in this case, we have to add 0 plus 1, which is our carry, and so the final result is 1001, which in binary number is 9. And by the way, you see that the result has more bits than the two numbers. Here we have 3 bits number, and the result has 4 bits. When the number of digits of bits of the result is greater than the number of digits of the two numbers, we call it overflow. We'll come back to this topic in future videos, and we'll investigate it further. And now I want to study the sum of two bits and see how it works in details. For example, I want to sum these 2 bits here. And in general, we have to sum the first, the bit number n, which this n is a generic number. For example, the bit number 1, in this case, this is 0, this is 1, so this should be A1 plus B1, so I mean the two corresponding bits of the two numbers, and plus the carry, the possible carry from the previous addition. I notated it in this way, carry n minus 1. So if I want to add up, for example, the A2 plus B2, so these 2 bits, I have to use the carry from the previous additions, so the carry C1. And the result is 2 bits, a bit for the sum and a bit for the carry, the next carry. So in general, we have to sum up 3 bits, and we obtain as a result 2 bits also. One is the sum and one is the carry. We can write this using a truth table, and here I put all the possible combinations, all the cases of the 3 input bits, which are A, B, and the carry input. I notated this one as CI, and here we have the columns of the results, which are a sum and a bit of carry out. This is the O here. So in the first row, we have to sum 0 plus 0 plus 0 of carry, and of course the result is 0 of sum and 0 of carry for the next sum. And in this case, we have 0 plus 0 plus 1 of carry in, and the result is 1 and 0 of carry. And in the next rows, the situation is the same. And more interesting is this case in which we have 2 bits equal to 1s to sum up. And so the result is 0, because 1 plus 1 makes 1, 0, makes 2, 1, 0 in binary, like in this case. And we have to write down 0 and have a carry of 1 for the next sum. So in the same way, we can fill the next rows of our truth table, and you see that the only different case is the last one, in which we have 1 plus 1 plus 1 of carry, and the result should be 3, but 3 in binary is 1, 1. And so we have, in this case, to write down 1 and have 1 of carry. So in the next video, we'll use this truth table to build the circuit as a starting point, to develop a circuit capable to make automatically the sum of 3 bits. Let us see in the next video, and goodbye for now.